All right, question number 2. Question number 2A says simplify x squared plus 7x over x squared minus 49. I think we did a question like this recently, and this is what I said to you. To do a question, to simplify a fraction, this type of fraction, what you have to do is you have to factorize the numerator, factorize the denominator, and if there are common factors in the numerator and the denominator, you would cancel them. Now, if we factorize the numerator, we're going to get x into x plus 7. If we factorize the numerator, we get x into x plus 7. The denominator, in the denominator, we have the difference of 2 squares. When you factorize the difference of 2 squares, this is what you have. You would ask yourself, what do I multiply by itself to get x squared? The answer is x. You write the x in both sets of brackets. Then you ask, what do you multiply by itself to get 49? The answer there would be 7. In one of the brackets, you would put x plus 7. In the other, you would put x minus 7. You will notice that x plus 7 is common, is the same in the numerator and the denominator. They're common. So you would cancel the x plus 7. And in the numerator, what remains is x. And in the denominator, what remains is x minus 7. Now, since this fraction cannot be further simplified, x over x minus 7 is your answer. B says, find the value of r when x squared multiplied by x to the 6 is equal to x to the r. X squared multiplied by x to the 6 is equal to x to the r. So, well, first of all, the law of indices says a to the m times a to the n is equal to a to the m plus n. So in other words, if you're multiplying and the base is the same, you must add the indices. So over to the left, now over here, x squared times x to the 6 would be equal to x to the 2 plus 6. And this is equal to x to the r. Over the left now, we have x to the 8 is equal to x to the power r. Now at this point, if the base is the same on both sides, if you have one term on the left, one term on the right, and the bases are the same, the powers must be equal. Therefore, r must be equal to 8. Stay with me. For I, we're told that we're asked to find s when s to the 3rd is equal to 8. Now, s to the 3rd is equal to 8. Now, 8 is the same as saying 2 cubed. So this is s to the 3rd is equal to 2 cubed. So here we have one term on the left, s raised to the power 3, and on the right, 2 raised to the power 3, and they are equal. Therefore, the base on the left and the base on the right must be the same. S must be equal to 2. Continuing, C says, the diagram below shows a triangle and a quadrilateral. All angles are in degrees and are written in terms of A and or B. For the triangle, 2A plus 5B is equal to 171. For the triangle, that 2A plus 5B is equal to 171. Well, that's not difficult to do. The angles in a triangle must add up to 180 degrees. So 3B plus A plus 2B, which is the second angle, plus A plus 9 must be equal to 180 degrees. Let's add the like terms. We have what? 3B plus 2B is 5B. A plus A is 2A plus 9 is equal to 180. Then 5B plus 2A is equal to 180 minus 9. Therefore, 2A plus 5B is equal to 171. We're asked to show that 2A plus 5B is equal to 171. For the quadrilateral, show that 7A plus 8B is equal to 342. Now, the angles in a quadrilateral must add up to 360 degrees. Starting at 6A, we have 6A plus 3A plus 2B plus 3B minus 2A plus 18 plus 3B is equal to 360 degrees. Let's simplify the left side. Let's add like terms. 6A plus 3A is 9A. 9A minus 2A is 7A. Let's look at the B's. 2B plus 3B is 5B. 5B plus 3B is 8B. So this is plus 8B. And then the only numbers we have on the left, or the only number we have on the left is 18 plus 18 is equal to 360 degrees. So 7A plus 8B is equal to 360 minus 18. 7A plus 8B is equal to 342. And of course, this is degrees. Triple I says, solve the pair of simultaneous equations. So now we have 5B plus 2A is equal to 171. That's equation 1. And we have 7. Let's go back. Now we have, let's write it differently. 2A plus 5B is equal to 171, equation 1. 7A plus 8B is equal to 342. This is equation 2. So you have your choice of options. You could either use your substitution or you could use elimination. I'm partial to elimination, but let's go with elimination. I'm going to eliminate B. To eliminate B, the number in front of B must be the same in both equations. To achieve that, I'm going to multiply, and do not let the big numbers scare you. Well, I could also just eliminate A. Let me eliminate A. You'll get smaller numbers. To eliminate A, the number in front of A must be the same in both equations. To get them to be the same, I'm going to multiply equation 1 by the number in front of A in equation 2. I'm going to multiply equation 1 by 7. So 7 2s, I have what? 14A, 7 5s, 35B is equal to 7 times 171. This is 1,197. This is equation 1 multiplied by 7. Then I'm going to multiply equation 2 by the number in front of A in equation 1. I'm going to multiply equation 2 by 2. 2 7s, 14A, 2 8s, 16B, 2 times 3, 42 would be 684, equation 2 times 2. Then I'm going to subtract to eliminate A, because 4A minus 4A is 0. 35A, sorry, B minus 16B, I end up with 19B is equal to 1,197 minus 684, that is equal to 513. Then I'm going to divide both sides by 19 to get that B is equal to 27. Then I'm going to substitute this value for B, 27, in any of the original equation. So I'm going to put it in equation 1. For equation 1, I'm going to have 2A plus 5B, but remember B is 27, is equal to 171. 2A plus 5 times 27 is 135, is equal to 171. 2A is 171 minus 135. So 2A would be equal to 36. Divide both sides by 2, and we get that A is equal to 18. And that said, we're at the end of the question.